Greetings. This is an explanation video for the event RECode 2.0 or record of conducted by the coding club PSGCT. So I am ANBU SELVAN M 22 is a 210 of BECSC one of PSG College of Technology. This is an explanation video for the two problems which were solved in the examly portal. And the first problem here is capacity to ship packages within D days, and the second problem is uh, container with most water. The explanation video contains the algorithm which I used to solve, and the test cases passed, and the time complexity which is of my algorithm which I used to solve the problem. So the this is a order in which the explanation video is presented. So let's move on to the first problem. So the first question here states that capacity to ship packages within D days. I have used your binary search and greedy technique to obtain the optimal solution. First, I went on to the solve with a brute force solution, which will be explained in the process. So we are given weights array, which is 1 to left. Let's take for example 1 2 3 4 5, and we are given days, which is equal to 2. So we have to find the minimal capacity to load these weights into the ship within the given number of days. We have to find the minimal capacity. So let's take for example capacity is equal to 1. We have to load only one chunk into the ship, which will take us 5 days and not 2. So this is not an optimal solution, because we have it will take 5 days, not 2 days, to load the weights into the ship. So I found that minimal capacity will be the max of it. That is, a lower bound which we should take must be the max of weights, which here is 5. So let's take capacity is equal to 5. So when we load these chunks, 1 plus 2 is equal to 3. When we add, we cannot add 3 because it will become 6. So 1 2 and then 3 and then 4 and then 5, which will take us 4 days and not 2. So likewise, if we go for each capacity for example 6 7, it will take us O n square complexity, which is a brute force method, which I first figured out. Then I went on to ask a question: if there is lower bound, then there must be an upper bound. So I found that lower bound is a max of age, then upper bound is must be the sum of age. It cannot exceed above the sum of age. So here the sum of age is 1 plus 2 plus 3 plus 4 plus 5, which equals 15. So so as there is a lower bound and there is upper bound, I used binary search algorithm to find the minimum capacity. So let's take mid. Lower bound here is 5, and upper bound here is 15. So mid is equal to 5 plus 15 by 2, which is equal to 10, and here the capacity is equal to 10. So when the capacity is equal to 10, there is we can add these 4 chunks as a chunk to the ship, which is equal to 1 plus 2 plus 3 plus 4, which is equal to 10, and then a 5 chunk, the fifth, and the only one chunk into the ship. So this will take us 2 days, which is satisfied. But we need to find the minimal capacity, where greedy technique comes into play, and a greedy technique comes into play. So uh, there is a, I have shortened the search range, for example lower bound, and I have shortened the upper bound to mid minus 1, which is 10 minus 1, which is 9. So I found the mid, which is equal to 5 plus 9 by 2, which is equal to 7. So in a seventh, when we take the capacity is equal to 7, we cannot load these 1 2 3 4 5 in 2 days. So fast forwarding to 8 and then to 9, I have increased the lower bound, which is equal to mid plus 1, and found out to be 9. 9 is the minimal capacity. For example 1 2 3, we can add this 5, which will take us 2 days. So this is the algorithm I have used. So the now let's talk about the time complexity of this algorithm. So initially I thought, for example, we should iterate to the weights array once, so it must be n, and the time complexity of the binary search algorithm here might be log n. Initially I thought that the time complexity will be n log n, but the search range can be from 0. The lower bound can be anything, so can be 0, but we should approach this problem in the worst case. So the time complexity will be n dot log m. Must be the upper bound, which is the sum of weights. So because the lower range can start from 0, and we should only take care of the sum of weights which is in the upper bound. So the time complexity of this problem is n dot log m. This is the first question. Capacity to ship packages within areas, as we already saw about the problem statement and example and algorithm before. Let's move on to the coding solution. First, a function here is a def valid capacity, which is used. I have written the solution in Python. So the first solution function here is valid capacity, which is uses greedy technique to find the number of days and the max capacity. So iterate through the weights, and if the max sum here, which is initially 0, is greater than max capacity, add the days, and update the max sum here, which is equal to the weight. And if the days is greater than max days, as we want to ship the packages within the days, if the days exceeds the max days, return false, otherwise return true. This uses a greedy technique. And let's move on to the solution. As I already told, I used the binary search recursive algorithm. Here the left is lower bound is the max of weights, and the upper bound is the sum of weights. Initially result is kept to v minus 1, and if left is greater than right, return nothing, which is a base case. And we want to find the mid, and this condition is here to is same as left plus right and integer division 2, but is here to avoid the overflow. And check the valid capacity function, passing weights, objects, maxes, and mid here is the maximum capacity first. So store the result, store the mid in the result away. And as we want to find the minimal capacity, as we want to find the minimal capacity, you should use recursively called binary search from lowering the range from left to min minus 1. And if the valid capacity is false, go to the else part and increase the search range from min plus 1 to the right. And you can call the function binary search recursive. Left here is max weights, and the right here is sum weights outside the nested function, and return the results. And these are the utility functions used to obtain the input from the user. As you can see, all the test cases are passed here. And this is the um, coding and algorithmic solution for the first part. Now let's move on to the second problem. So it's which states that the container with the most water, and I've used a two-pointer algorithm. We have given a ith array, which and ith index denotes the ith. For example, the first ith here is 1, so I plotted in the graph 1. Likewise, I plotted all the other iths, and we have to find the container with most water. And here which is second ith, which is 8, and the last ith, which is equal to 7. So we want to return the maximum area of the container with the most water. So the max area here is, as mentioned in the example, is 49. So let's use the two-pointer algorithm. First, I initialized two-pointer algorithm with I is equal to 0 and j is equal to n minus 1. N here is equal to 9, so I initialized n minus 1, which is equal to 8. So the first now here the first height here is height is equal to I first here is heights of height 1 is equal to heights of I, which is here is equal to 1. And height 2, similarly height 2 is equal to heights of I j, which is equal to last height, which is equal to 7. So we want to find the minimum height, because finding the minimum height can accommodate the most water, because we can accommodate the most water. For example, I is equal to 1 can contain water in this area. When we take I is equal to 7, the maximum height, we cannot contain that area, it may overflow. So we want to find the minimum height. Here the minimum height is equal to 1. And to find the area, we must multiply the height with the width. So here the width will be j minus I. So this is the width for the first channel, this is the width, which is equal to j minus I. So here the j minus I is equal to 8 minus 0, which is equal to 8. So the maximum area here is equal to 8. Similarly, we want to keep max area which is initialized is equal to 0 and update it accordingly. So here now the max current area, this is the current area, so it is greater than 8, so we should update the max area is equal to 8. Similarly, now we should update the pointers accordingly. So if h1 which is height 1 is lesser than height 2, we must increase the I pointer as stated as because of the two pointer algorithm. If it is height 1 is lesser than height 2, we must increase the I pointer, so the I must become 1 and j remains same. So similarly update the pointers accordingly. So we must iterate until I is lesser than j, so we can find the max area, because the two pointers should not cross, so we must iterate until I is lesser than j. So then let's demonstrate this example for the second, and remaining will be done the same. So the first j is equal to 1, so the max area now is equal to 8, and height 1 is equal to 1, height 1 is equal to 8, and height 2 is equal to 7. And now the current area must be, the minimum here is 7, and star the width is equal to 1 minus 8, which is equal to 7, must be equal to 49. And now the max area is 8, and now the current area is greater than max area, so we should update it accordingly. So max area is now equal to 49. Similarly, the max area, the I and j will be executed at most n by 2 times, as the two pointers cannot cross, so I and j must be executed at most n by 2 times. So the time complexity of this algorithm might be 1 is equal to 1 by n by 2, and the order of growth, removing the order of n might be o by o n times. So this is the algorithm using the container two pointer algorithm for the container with most water. The time complexity here is o of n. As we already saw about the algorithm for the container with most water, and already explained the problem statement and example, let's move on to the coding solution. And I have solved this in Python as well. So the max area function takes the heights parameter and the length of the height and length of the heights array as input, as parameters. So first I initialized I is equal to 0 and j is equal to n minus 1, which are the two pointers, and I have initialized max water to be 0. And now I will iterate until I is less than j, that is a left pointer is lesser than right pointer, and I will take the heights accordingly. H1 must be the height position of heights array, and H2 will be the jth position of heights array, and I have to find the minimum of both, as I already explained. Why should I take the minimum? And I have to calculate the width as well to calculate the area. So width can be calculated by subtracting j from I, and you should calculate, and I should calculate the area. This current water is equal to width star h. So width here is j minus I, and h is a minimum of 2 i's, and update the max water accordingly. So if the current water is greater than max water, update the max water, and update the pointers accordingly. If h1 is lesser than h2, increment the I pointer, hence increments the j point, decrement the j pointer accordingly. So this is the two pointer algorithm, and return the max order. And I already told these are the utility functions to receive the input from the user, and these are the test. As I already, these two problems were solved in example. You can check it out, and as you can see, the test cases are passed, and these are the results of the test cases which were successfully passed. Thank you.